Hello, everyone. Thanks for joining the session about AWS Network Simplified, a comprehensive tour of key features. My goal today is, of course, to cover some of the key components on networking. Because time is limited, I won't be able to cover all the network components, but I'll try to focus on the core networking components. So just to set expectation for the talk today, we are not going to go in depth into application architecture. We're mostly going to be talking about how can you understand some of the core networking fundamentals and some of the features that you can use for your organization or your personal use to use the best of AWS. So a quick introduction, my name is Samuel Barufi. I am a senior solutions architect here with AWS, and I focus on supporting global financial services customers on their cloud journey. So without further ado, let's get started. Quick agenda, we're gonna quickly talk about global infrastructure on AWS, some of the components. Then we're gonna dive deep into VPC. We're gonna talk about VPC security after that, we're gonna actually go to the meat of the presentation, talking about peering, endpoints, gateways, and global connectivity. What are the things you can use to really expand the capabilities of your AWS network and also potentially hybrid into your hybrid cloud. And to finalize, we're going to talk about a new service that was introduced last year, which is very exciting to simplify service-to-service connectivity. This is the one that will talk most about application connectivity. And we're going to end the presentation talking about some of the tools that can help you operationalize your network, such as how can you have visibility into your traffic and how can you monitor your traffic. So let's quickly talk about global infrastructure on AWS. So the global infrastructure on AWS is a forever growing footprint. As of today, and this is very important, this might change in a couple of days, weeks, and months, we have launch and available for you as a customer to consume 32 different regions across the globe, as you can see on this screen, with a total of 102 availability zones and more than 450 points of presence for CloudFront distribution. The latest region that was made available a couple weeks ago was Israel. So how does AWS backbone infrastructure treats fault tolerance? So it's really important to understand that all regions are comprised of multiple availability zones for high availability and scalability. So if you look on the slide, you have a region. Within a region, you have multiple availability zones that are interconnected. So each region has two independent, fully redundant transit centers. So that's where the traffic goes. That connects the transit center connects your region and the AZs that the region are part of to the bigger AWS ecosystem network. And each availability zone is highly redundant, connected to each other within the region. And then within each availability zone, you might have one or more data centers that has independent power, networking, and connectivity capacity. The data centers, this is a completely abstract scenario, but this is just to paint the picture on how, when you actually get to the real data center, how we are abstracting that for you as a customer. So now that we know about the regions, the global infrastructure, let's talk about the first component, which is Amazon Virtual Private Cloud, also known as VPC. So when you're building a VPC is a regional construct. So you go to a region, in this example, you go to region US East 1, and then you create a VPC. The VPC stands for Virtual Private Cloud. It's your own private cloud. Nobody else has access other than you and your account. Within the VPC, you are actually gonna be, because VPC is a regional construct, you are gonna choose different availability zones that your VPC are gonna be spanning across. So in this case, just for demonstration, there are two availability zones, and you see that each availability zone will have a specific ID for your account. Then once you have the VPCs and you have the specific availability zones, you can create subnets within those availability zones. And you can have public subnets and private subnets. Public subnets means you can actually have a connectivity, both ingress and egress, to the outside world. Private subnets means, likely you are not going to have access to inbound connectivity from the internet. So, if you have a database, you might want to put that there. Once you deploy a specific resource, like in this picture on the public subnet, of course, that resource, let's talk about EC2, Elastic Cloud Compute, which is a virtual machine instance that you have on the cloud, is actually going to be hosted on a specific data center, on a specific rack, on a specific host, but that is completely abstract from you. So you don't need to worry about it. You just know that that EC2 is now running on a specific subnet, and that subnet is part of a specific availability zone. And then, of course, you're going to have an elastic network interface that connects the EC2 to the network on the subnet and on the VPC. Now, when we talked about an important aspect of networking, which is IP addressing, let's start with IPv4. How does that work? So I'm going back to the scenario where you have a VPC with 2 availability zones and 2 public subnets and 2 private subnets. The first thing you need to do is associate a CIDR range, so an IP address block, to the VPC. In this case, 10.0.0/16. Now, you go and you slice that big subnet from the VPC, and you decide smaller subnets that are part of that big VPC subnet into your small subnet. So public subnet, you're going to have a /24, and then the private subnet, you're going to have a /24. If you're not familiar with, subnets on IP addresses, the slash after that just mean the amount of bits that you're going to have available to actually consume within the subnet. So, every single CIDR block that you see on the subnets are part of the bigger VPC CIDR block. Then, when you create specific resources, in this case demonstrating on the public subnet, on both public subnets, you're going to have a resource and you're going to have what we call ENI, Elastic Network Interface. That ENI will get an IP that is part of that specific subnet. So in the first example on the left, 10.0.1.38 is the IP address that your EC2 has been received. And on the other side, 10.0.2.200. You can have multiple IP address in an ENI, and there is some limits that we're not going to talk today. But you can also have 2 different ENIs on an EC2, and they can have different private IP address. So far, we are talking about private IP address. Another aspect that is important is VPCs can have secondary CIDR blocks. So in this case, let's say we have consumed most of the first CIDR block, because VPC's CIDR blocks, the primary CIDR blocks, cannot be changed. You can only add new. So you can have secondary CIDR blocks into your VPC. So you've added a new one. And when you look here, it's interesting to know that when you create subnets, you have IP addresses that are reserved. So the way it works is the first IP address is also going to be the network address. So you're not going to be able to use the first .0 network address. The second one will always be your gateway, the VPC router gateway. The .2 and .3 are reserved. Maybe AWS will use that for other capabilities in the future. So AWS reserves that it cannot be consumed by your resources. And the .255 is always the network broadcast. And it doesn't matter, each subnet will follow the same aspect, because each subnet requires these 5 IP addresses to be reserved, and each one will have a specific purpose. Now, when we talked about public IP address, you can have public IP address associated. And when I mean public IP address, I'm talking about IP addresses that are routable on the internet, different than the IP address we've talked so far. So we see here on this slide, you have an IP address that have been associated to an EC2. You can also have elastic IP addresses where you can reserve a specific IP address for your account. And the difference is on the public subnet on the left side, if you're just requesting an IP address on your instance, but you don't have an elastic IP address association, it just means that if the instance is terminated, you are not guaranteed to keep the same IP address. If you create another instance or you restart that instance, maybe the IP address might change. But if you have an elastic IP address, that IP address is reserved for your account, and you can always associate to a specific EC2 instance or change in the future. So highly recommend that we use elastic IP address. And like I said here, you can just move, okay, I want the IP address this time to be on this interface. If in the future you want that to be associated to another Elastic Network interface, you can definitely do it. So now let's talk about IPv6 addressing. So as we know, IPv4s, especially public IPv4s, are very limited, and IPv6 have been kind of comes in to provide that solution for the limit amount of IPs we have available. So AWS is highly supported and provides a lot of recommendations for customers to use IPv6. You can run IPv6 and IPv4s at the same time, also known as dual stack. So in this scenario, we're just going to look how you can add IPv6 into this architecture. So you can go on your VPC and associate it a IPv6 block, which is a /56, because now instead of only having 32 bits for your subnet as IPv4 have, you have 128. And instead of just being numeric, it's actually hexadecimal. So you have many, many more IP address. So associate to your VPC, you then associate it to the subnet, you do the slice again to the subnet, and then what you can actually do, you can see that some subnets can only have IPv4 address, some subnets might have both. In this case, you want a private subnet to actually have an IPv6 address, but the other subnet to not have. There might be use cases why you want to do that. Then when you create an instance, you can actually, if you see here on the left side, the instance can also receive a private, an IPv6 address that is local to your subnet. And the same reserved IP addresses that we talked on IPv4 are also valid for IPv6. You can see here the demonstration, that will be reserved from the specific, a /32 will be reserved, /64 is the VPC router, and you can see the example on the right here. So continuing here, how does intra-VPC routing works? So within the VPC itself, right? Intra-VPC means just within that single VPC. In this case, every time you add a specific subnet to your VPC, by default, the route table that you're going to be associated, that is showing here on the screen, is going to create a local target, meaning it doesn't need to route any traffic. It's already know because it's within the VPC. And you're going to point all those subnets into this routing table. So if you need to talk from subnet 1 to private subnet 1, assuming you have specific security permissions to do that, route-wise, you are fine. Network-wise, you're fine. Now let's talk about some of the VPC security components, which is important, right? We talked about the network layer. Let's talk about what the security network features of VPC are made available. So by default, security groups are attached to resources like EC2s, and it's a very important way for you to decide what is allowed for inbound and outbound. So by default, the default security groups will always be that no traffic from outside, no traffic will be able to come into resource, but always traffic will be able to go out of the resource. So that is the default group rule for a security group. When you want to provide a web server example, let's say you have an EC2 that is part of a subnet, and you want to have, maybe internal or external, whatever that may be, you want to provide access from a specific port. In this case, we are allowing TCP port 80, which is the HTTP port. And when you see the source, 0.0.0.0/0 means everybody. Unless you know what you're doing, you should always avoid to do 0.0.0/0 because everyone, even if you have a public, especially when you have a public IP address associated to that security group, it means everyone will have access to that. So be careful when you do that. But then you can also have reference other groups in your security groups. And this is something not a lot of people are familiar, but it's a very nice way. So here, let's assume you have a EC2 instance that is a web server, and you have a database EC2 instance that is a database. Each EC2 has a different security group. So you have a web server security group and you have a database security group. Let's assume you want to give access from the web server EC2 to actually communicate with the database EC2. With the database EC2. What you do here, instead of actually, allowing from everything, and you could potentially just put the private IP address of the database security group, but then if the IP address change or if you increase more instances, it's hard to maintain. What you can do is, as the source, so if you look on the right here where it says database security group inbound rules, you are saying, please allow the port 3306 on the protocol, on the TCP protocol from the source security group web server. So whatever resources have this security group associated to will actually have access to talk to your database. So instead of putting IP addresses, you can put security groups references. And this is very, very helpful. Another example is self-referencing rules. So let's say you have multiple resources, EC2s, that are using the same security group. And you actually want to give access across these resources, for them to talk to each other. You can actually do a self-reference on the same group and decide what is the inbound port that is allowed. So in this case, you just put port 80 and, every single resource within this security group will be able to consume port 80 across the security group resources. One thing that is important to be aware with security groups, it means they are stateful. You only need to open the port, that you require access. You don't need to think about the port that is coming back. And the reason why I'm talking about that is you also have another aspect of security on your network that is talked about, network access control, also known as NACOs. NACOs, instead of actually being associated to a resource like an EC2, they are associated at a specific subnet. And different than security groups, NACOs, network access control lists, are stateless, meaning if you're allowing something to be accessed, you need to think about the traffic both ways. So there is something called the thermal ports. So if you're allowing something to go on port 80, you need to allow the thermal ports to be, outbound as well. Just a small gotcha that I want you to know. But with NACOs, you can actually have you can have inbound and outbound rules similar to the security groups that are going to be evaluated at the subnet level. So you can actually both security groups and network access control lists work at the same time simultaneously. One is at the resource level and one is at the subnet level. So be careful when you're using NACO. You just want to make sure you know what you're doing. So we talked about VPCs, VPC securities. Let's just get a little bit more advanced here on peering, endpoints, gateways, and global connectivity. So first, we're going to talk about NAT gateway and internet gateway. What are the differences between them? So going back to the example where you have a VPC and you have a VPC with dual stack, so you have IPv4 and IPv6. Every time you want to have any instance to communicate to the outside, you need to deploy an internet gateway. The internet gateway is just a resource that easily you create and you associate to a VPC. So in this case, you have an internet gateway, it's associated to the VPC. Then you just have a routing table that says, everything that it needs to go, everything that is not specific. So 0.0.0/0 or ::/0 for IPv6, forward that traffic to the internet gateway. So everything that needs to go outside will go to the right internet gateway route. So in these cases, because you have IP addresses that are public, in this case you have IPv6 on the left private subnet, will go through the internet gateway. Now, you can also have NAT gateway, and NAT stands for Network Address Translations. NAT are specific for IPv6, IPv4, mostly IPv4. What NAT does is allows private subnets that don't have public IP address to have outbound, so traffic going out, connectivity to the world. So if you look here, this is the configuration we currently have, right? And you don't see, and you have deploy NAT gateway. So the NAT gateway you deploy in a public subnet because the NAT gateway needs to have a public IP address to communicate with the internet gateway. What you can do is on your private subnet, you can say everything that needs to go out to the internet, instead of talking to the internet gateway, because it cannot talk to the internet gateway because the resources on the private subnet do not have public IP address, I want you to forward the traffic to the NAT gateway. And you deploy NAT gateway across subnets into different availability zones for redundancy reasons. And once the traffic goes to the NAT gateway, because it has a public IP address, will send the traffic to the internet gateway. So in this case, the private subnets are only able to go outbound connectivity because the private subnets here on the right don't have a public IP address. They don't have the ability to actually receive inbound traffic, which is good because you want to have security. Let's say you have a database, you don't want the database to have a public IP address. So another scenario here, another type of internet gateway, and this is very specific, it's called the egress-only internet gateway. Because on IPv6 we are not doing NAT, and you can see that on my left private subnet, I have an IPv6 address. If I only want that IPv6 to be able to send traffic outbound, so egress rather than inbound, I can create an egress only. And then I can associate it into this private subnet. I can associate a routing table that says, if you need to go out, use the egress only internet gateway. What this will do is will block the ability of this IPv6 to receive traffic from the internet. So you can only initiate traffic to the internet, but not traffic coming from the internet to your IPv6. This is a very recommended way once you want to have IPv6 on your private subnets. And you can just associate it. So in this case, the full solution will kind of be this, right? You have some subnets, in this case, the public subnets who talk directly to the internet gateway, but then you have some subnets, in case the private subnets that in the IPv6 will talk to the egress only internet gateway, and IPv4 will talk to the NAT gateway specifically. So you can use a combination of these tools to achieve the specific use case you are trying to do. Now we talked about peering and we talked about NAT gateways and internet gateways. Let's talk about peer with transit gateway, endpoints, and other types of peering. So let's talk first about VPC peering. Let's assume you have a scenario, you have two VPCs, right? And those VPCs need to talk to each other. So you have maybe resources that are across VPCs and you want to connect them together. You can use what we call the VPC peering connection. You literally just choose a specific VPC and the other VPC, you link them together. Always a one-to-one relationship. And then on your routing table on both sides, you specify, the IPv4 or IPv6 and IPv6 address that is on the other side and how you can get there. So in this case, if you want to go from the VPC on the right and you want to access the VPC on the left, the IPv4 on the VPC on the left is 10.0.0 is like 16. And how you get there is going through the peering connection. In this case, is PCX-1234 address. So very simple. There is no additional cost, only the data transfer cost that is associated with VPC peering. Now, there is a challenge with VPC peering. Let's assume you have 1, 2, 3, 4, 5 VPCs created. And let's assume each VPC needs to be able to talk to each other. Now you're getting to the sense that because VPC peerings are one-to-one relationship and they cannot hop over, you need to create, so if you have, each VPC in this case, you need to have 4 peering connections attached to it. That becomes really hard when you have a lot of VPCs and really hard to maintain. And that's why AWS released a service called Transit Gateway. Instead of having that complexity network of multiple peers, what you can do, you can create a specific AWS Transit Gateway on a specific region. So we're talking about the regional construct here. And then you can create a single attachment for each VPC. So you have attachment 1 goes to VPC 1, attachment 3 goes to VPC 3 within a single region. Then you have different routing tables on the AWS Transit Gateway saying that, okay, if VPC 1 wants to talk to VPC 4, the way it gets to that traffic is going by attach number 4. Or if it wants to talk to VPC 5, it goes to attach number 5, and so forth. So you can see here where you can have a centralized routing table that can aggregate everything together, and you can exponentially add more VPCs, and it's just going to be an entry on your routing table and an attachment. You don't need to have multiple managements of VPC peering as you had with the VPC example before. Now, the cool thing about Transit Gateway is it also supports multi-region, which is very exciting. So in the example here, let's assume you have let's say you have 4 regions. You have, region 1, region 2, region 3, and region 4. And you have a couple of VPCs within the region. And you already have maybe Transit Gateway deployed within the region. How about if maybe for a multi-region architecture or maybe DR purpose, the resources across regions needs to talk to each other? It's not that hard. With Transit Gateway, you can create Transit Gateway peering attachments. So you can have different Transit Gateways across the region that are peered with each other. And then in this scenario and this diagram that I'm showing, you're actually able to consume across different regions. So kind of moving into another aspect is every time you need to consume. So let's say you have in this example, you have this EC2 that is sitting on the private subnet. If I need to access services, AWS Services API, let's say I want to talk to a specific KMS key API. The way it works is, by default, is you're going to have an internet gateway in your VPC. Because this is a private resource, you need NAT gateway, and the traffic will go as follows. We're going to have the routing tables. The routing tables will tell, okay, if you want to talk to anything in the internet, go through NAT gateway. NAT gateway, go through internet gateway, then go through the internet and then talk to the public API of these services. Let's say the public API of KMS. This is okay, and this is the default behavior. The challenge here is you're sending traffic over the internet. Even though these API calls are encrypted in transit, it's going through the internet. There are occasions you do not want to use the internet. How can you do that? Well, you can use something called the VPC endpoints. So what the VPC endpoints is, in the same scenario, you have some services here that you want to consume. In this example here, some list. Now what you can do, you can create an interface. There are 2 types. First, we're going to talk about the interface endpoint. When you create an interface endpoint, you choose what service that interface is going to be able to allow consumption for you. So let's say this is KMS. What the interface endpoint will do, you create a specific Elastic network interface within your subnet, and you can associate your interface endpoint through multiple subnets. And let's give the example, you want to go to KMS again, but you don't want to use the internet. You want to use the AWS backbone connectivity that never touches the internet. With interface endpoint, every time you have a resource that wants to talk to a specific API or a specific resource on AWS, you go directly. So the error that you see here is using the AWS backbone connectivity. You're not going to the internet. And in this case here, you don't even need a NAT gateway or an internet gateway, because let's assume this EC2 does not require internet connectivity, just requires some API services on AWS connectivity, like talking to KMS or maybe grabbing a file from S3. You don't need to do that. So the solution behind the scenes is using Private Link, which we'll talk in a moment what Private Link does. But it's pretty much doing a magic. Every time you call a AWS API, there will be a DNS, and you automatically resolve the DNS into a private IP address rather than resolving into a public IP address. But there are types. There is a second type of endpoint that is called the VPC gateway endpoint. The VPC gateway endpoint only supports 2 services, S3 and DynamoDB. And the main difference is, instead of being an interface endpoint, meaning creating an Elastic network interface on your subnet, it's deployed at the gateway level of your subnet. So if you need to talk to S3 and Dynamo, you actually have a routing table. The routing table will send the traffic direct to your gateway endpoint, and then the gateway endpoint to talk to S3. There are some pros and cons on using one and another. Interface endpoints has vast support of services, but there is a cost associated. Gateway endpoints have just limited 2 services, and there is no cost associated. So your miles might vary depending on your use case. So the cool thing is you can also create a specific endpoint policies. So on your VPC endpoints, you can create a policy to secure what type of connectivity you want to allow. This is also known as a resource policy. In this case, VPC endpoint policy. It's following the same JSON policy as your identity IAM policy. In this example, I'm restricting only once I created an endpoint, and with this specific JSON policy, what I'm saying is this allows for any actions, any resources, but only if the role that is trying to invoke this specific endpoint is the role that is associated here. But you can have very fine granular details on how you actually decide this. So it's just, hopefully you can arm your tool set of more things that you can do to secure your environment. Now, private link, right? So private link is the technology that runs on top of the VPC interface endpoint. The cool thing about private link is you can create specific solutions for your, like using the same backbone network, private connectivity of AWS. If you have consumers that wants to, consume services from you. So let's say you are a company, a SaaS company, whatever it is, that you are providing a service, and your customers, which are the VPCs on the left, want to consume your service into a private way within AWS, but you have your account and they have their own account, and you have different VPCs. What you can do is you can create a private link service which deploys an interface endpoint on the consumer VPCs, similar as we've seen the endpoint VPC interface that I just talked about it. And then you can deploy your application. And the way you do, you just deploy a network load balancer and you put your application behind the network load balancer. So when the consumer VPC is talking to your application, you actually will be using the interface endpoints and using the private backbone of AWS to talk to your application. So hopefully you can use this to really provide better private connectivity for your customers. So now we're going to talk, there is one more thing that I want to talk about it is once you have a global connectivity, maybe hybrid cloud, what are the options available for you to consume? So let's talk about hybrid connectivity and DNS. So first we're going to talk about Direct Connect, site-to-site, client VPN, and then Route 53. Let's start with Direct Connect. Direct Connect allows you to connect your data centers or offices by literally having a direct cable connecting you and AWS. So you have a region on AWS and you have your data center. Then you choose a specific direct location. There are partners direct connect locations, or there are AWS direct connect locations. There is literally a cable, a fiber cable, a private fiber cable that will be connected between your customer router on your data center and the direct connect router. Then you have resources on your region, and you can actually access privately from your data center, going through the private cable that you run into Direct Connect, and then Direct Connect will connect your specific AWS account. This is very commonly used when you have a hybrid connectivity for your specific AWS accounts. And here you have a Direct Connect gateway, and you can also, with Direct Connect gateway, you can use one thing here, what this picture is saying, like you can have different types of Direct Connect. One type of Direct Connect is just allowing your data center or corporate office to access a specific AWS APIs, in a private scenario. But you can also have a Direct Connect gateway that allows the traffic from your on-premise data centers to connect to the resources that exist on your AWS account. So you can see here how this gets together, right? Like I kind of connects them together, and then, it's all, in this case, if you want to encrypt, you can actually put a VPN on top of that, because by default, the traffic between your data center and the Direct Connect, even though they are private, they are not encrypted by default. So you can put a IPsec VPN, which this is decrypting, this is showing for you that you can achieve. But now, if you don't want to pay a lot of, if you don't have a lot of resources and you don't have a lot of time and you don't require a lot of bandwidth, you can just use a site-to-site VPN. With site-to-site VPN, you have your on-premise network, you have your own router, then you create a virtual private cloud on the cloud, you create an IPsec VPN, which is using the internet. So rather than have a private connectivity, even though it's secure and encrypted, is actually using the internet as a way to talk to your resources. So how would use? You can actually now put together everything that I just talked about with Transit Gateway. So you can have a Transit Gateway that has VPC attachments, and then you can have VPN connectivity, across multiple on-premise networks. Let's say you have multiple private branches or data centers. Instead of having to connect to each VPC, you can have the Transit Gateway being the centralization. So apologies. So the Transit Gateway will not only solve your problem internally within AWS, but also for your hybrid cloud. Now there is another type of VPN, which this is very specific. It's called a client VPN. Let's assume you have developers that want to have private access to your AWS network running on their laptop. So maybe they're working remote and you want to provide them the ability to consume resources that are available within your AWS. So you deployed a service called the client VPN endpoint. You can install a software on developers client laptop, and they're going to connect to the client VPN endpoint. And then they're going to have access to your VPC endpoint. In this case, the 10.1.0 is /60. I'm just going to take up a sip of water. So this is a way you can achieve that. So it's fully managed. You don't need to do anything. It supports split tunneling. So it means that, if you only want to send traffic for the IP address from specific subnets or the whole VPC, you can support that. Or, you can send all the traffics, even internet traffic, to your account. And you can also do client authentication using Active Directory or other types of federation. And in the end, you provide client-to-client connectivity. Even like you can actually talk to each other if you deem necessary. So how do we bring all together? So in this case, you have a region, multiple VPCs, and you have maybe a couple of data centers. So here you have a NAT gateway. We talked about the internet gateway, egress only for IPv6. You have Transit Gateway connecting different maybe VPCs, or you can choose to have a VPC peering endpoint. You can have specific endpoints if you're consuming specific services, but then you can have direct connect from your on-premise branch or maybe data center. You can also have direct connect gateway if you want to access those resources, or you can choose to have a VPN site-to-site connectivity. So I know this is a lot, but this is to show you that the capabilities and choices are here for you to choose. One thing I want to talk about is DNS quickly. So Amazon Route 53 is the DNS service on AWS, and Amazon Route 53 Resolver allows domain name resolutions to be done internally, kind of super transparently. So all the Amazon provide DNSs, which is the VPC +2, are done automatically if you choose when you're deploying your architecture. So you can support DNS host names, you can have private host names. So when you create an EC2, you can have this private host name. The reason why your VPC will know how to resolve this is because Route 53. So, these specific DNS can be resolved to a specific IP address because the Route 53 resolver for VPC is available. You can also support resource-based private VPC. So in this case, it's using the resource-based IP address, not the DNS with the IP address itself. You can also resolve public DNS names. And it's as simple as on the VPC, you can just decide if you have DNS host names and DNS resolution enabled. By default, those are enabled. So let's talk about the simplified. So we talked about a lot of things that are not very specific to application, but I just want to present to you, again, to have that on your toolbox is a service that can simplify server-to-service connectivity. The name of this service is VPC Lattice. VPC Lattice allows you to have a service mesh for cross-account, cross-VPC connections without having to managing peers, transit gateways, or like being worrying about overlapping side ranges with IP address or maybe IPv6 address. It supports a consistent number of services, compute services like EKS, EC2, Lambda, and Elastic Container Service, By default, it works at a layer 7 protocol, so you know how to do proper HTTP routing and so forth. And there is a lot of security being made available for you. So you can centralize the control of your inbound and outbound traffic for internal communication. How does that work, right? So let's say you have two VPCs, and you have a VPC where that VPC you have a service that is the parking service. And then you have another VPC that runs, it could be cross account, or it could be in the same account. And you actually don't want to create a VPC peering connectivity. You don't want to create a transit gateway. You don't want to create the routings. You just literally want to give the parking service access to the billing service. What you can do, you can easily have the VPC Lattice service network deployed across these two VPCs and connect the instance to the VPC Lattice service network. That will allow simple cross VPC connectivity without needing to manage anything that I just talked about previously. So this is kind of literally a mindset change on how you can architect your solutions. Let me give you more examples. Let's say you want to have different HTTP APIs and you want to decide specific path-based rules. So let's say you have a service, again, that is a billing service, and you have resources on that VPC, and you want to send that, depending on the path you go, so let's say you go /API/parking, you want to send that to a specific VPC that have its own resources that are managing the parking. Or when you go to /API/inventory, you want to send to another VPC. You don't need to do anything other than creating the routing rules on the VPC Lattice service network. So every time the service billing will go and talk to API inventory, the VPC Lattice service network will know what to forward to, in this case, the VPC tree. Another example is granular ways to secure access to service. So you can actually specify who are the consumers, in this case, the billing. You can say, you can have multiple services on your service network, and you can decide, for example, the billing service can only talk to the parking service. It shouldn't be able to talk to the inventory. You can create those rules, and you can have a lot of specific rules configured on the VPC Lattice service network saying the billing service only talks to the parking, not to the inventory. And you can have very complex and fine-grained permissions to achieve what we call zero trust. So another thing here that I want to show is, to kind of end the presentation, is how can you achieve traffic visibility and monitoring? So first is VPC flow log. VPC flow logs, here you just have an example, provides all the VPC data, like the traffic. If you enable, the traffic that is going on your VPC can be logged on a very specific format. So you can have, the version, the account, where it's going, what is the IP address, what is the region, what is the availability, so on and so forth. And then you can actually query that. Can be saved on CloudWatch or can be saved on S3, and you can actually query to see specific. In this example, it's like, hey, can I tell the connectivity between these two addresses, how much bytes have been transferred in this specific time frame? So you can do that with VPC flow logs. Highly recommend everyone to enable VPC flow logs, because that gives you the security and ability to inspect, what type of network connectivity have been enabled on your account. Another interesting feature that you can enable on VPC is called the traffic mirroring. So traffic mirroring is really important if you want to do traffic inspection or any type of security real-time capability, but you don't want to impact the performance of your current architecture. So what you can do, you can literally go and enable. In this case, there is no traffic enabled, but you can enable now a traffic. And once you enable, so you click to enable the traffic, what does it do? Every single packet that is being sent, your specific VPC will work properly, but once you enable VPC traffic mirroring, you can create a monitoring instance. So you can create your own traffic analyzer using open source traffic analysis or using AWS traffic mirroring partners. Every single packet that is sent to your VPC will be replicated and mirror into that specific ENI, and then you can create a lot of specific security inspections in real time. And that concludes my presentation. I hope you were able to learn some of the key components. I know there was a lot that I covered and I kind of went a little bit quickly. If you have any questions, feel free to connect with me on LinkedIn. My name is Samuel Barufi. I appreciate your time. Thank you so much, and bye-bye.